Of course, our calculus lives would not be complete without some type of application of partial derivatives. And this is just the tip of the iceberg. We'll be doing lots of applications eventually of partial derivatives. All right, so this is going to be interpreting a partial derivative as a rate of change because, of course, like any derivative, it is a rate of change. So we have the body mass index, BMI, is given by the function B equals m over h squared, where m is the mass in kilograms and h is the height in meters. I know in Fall 19 it actually said W in weight, but it's mass. It's the body mass index, not the body weight index. So please fix that. Sorry about that. Okay, so let me rewrite this just real quickly. That'd be the same as B equals m times h to the negative 2. Just keeping that in mind. Okay, so I want to find the rate of change of BMI with respect to mass, not weight, sorry, mass, and interpret the results. Okay, so I want to take the partial derivative of that body mass index and with respect to mass, m. So that means that you treat the h as if it's a constant. So it'll just be h to the negative 2 times the derivative of m. But the derivative of m is 1. So that would be 1 over h squared. All right, now let's think about what this means for a second. Height is always positive. And that means that since the partial derivative of body mass index with respect to mass is related to the height, and that since this is always positive, that means that the partial derivative of body mass index with respect to mass is also always positive. So if I think about this, as mass increases, right? If we move to the right on the mass axis, then the BMI also increases. So just think about this for a second. Height is always positive. Since height is always positive, 1 over h squared is always positive. Since 1 over h squared is always positive, that means the partial derivative of BMI with respect to mass is always positive. And if that's the case, if this is positive, what that means, what positive is by definition, means that as your independent variable increases, your dependent variable also increases. All right, I should underline both of this. So as this one goes up, this one goes up. That's what it means to be positive, right? Okay. Now what about the partial derivative of BMI with respect to height? So we leave the mass as constant and we take the derivative with respect to height. So I'm terrible about the deltas. I know they look like 2's. I'm sorry. I'll try to be better about it. So this would be, okay, so the m is constant, so it's just going to be m times, and then the derivative of h to the negative 2 would be negative 2 h to the negative 3. Okay, but that's negative 2m over h cubed. Now let's think about this. Mass and height are always positive. They have to be. I mean, you're a human being. So mass and height are both always positive. Now, what does that mean for our derivative? That means that this derivative will always be negative because a negative times a positive over a positive cubed would be negative. So the partial derivative of b with respect to height is always negative. Now, what does that mean for the derivative to be negative? Actually, I'll do it in green right here. Okay, so if this is always negative, what does that mean? That means that as height increases, as your independent variable increases, which in this case is height, because that's the partial derivative I'm taking. So as height increases, BMI will decrease because it has a negative slope. So that negative means that as the x goes up, the y will go down. Or in this case, as height goes up, BMI will go down. Okay, so let's look here at this graph, which can be a little bit confusing. So let me simplify it a little bit. First of all, X and Y are a little strange. So this is height, which was in meters. And this is not X, this is mass in kilograms. And we have different BMI curves here. So this is the BMI 18, this is BMI is 22, this is BMI is 26, this is BMI is 30. You can just trust me on that, or if you wanted, you could graph it. You can graph W over H squared and you'll see that's what it looks like. And of course, there are actually multiple curves, and this is just drawing 4 of them. So let's think about this. If you look at the first one, as mass increases, so that means we're actually moving to the right along this. So if we start off here, let's say that we're a person that's 70 inches tall, and we have a BMI of, I don't know, 26. Let's say, just pretend that's your starting point. Ooh, I wasn't quite lined up with 70. I am off kilter. I have a little parallax issue right there. Okay, so here I am at the start. Here's my curve. Okay, so if I'm there at the start, and as my mass increases, I'm going to move this way. So if your mass increases, you're going to go this way along the curve. So you're going that direction, right? Increasing your mass, leaving your height alone, right? So if I do that, then as the mass increases, what's happening to the BMI? Well, you're moving from the 26 curve to the 30 curve, one would imagine, to the 34 curve right below it, right? So as mass increases, BMI increases. You're gaining weight, but you're not gaining height, right? So you're moving to the right. So I guess instead of putting arrows this way, I should have done it like this, right? As your mass increases, your BMI is also increasing. Well, I'll just leave it like that, though. Increases makes us think of up, right? But what we're really moving is to the right. So I'm going straight right, straight right. I didn't grab a ruler, so, right? As I do this, my mass is increasing, so my BMI curve is going to get bigger. So I have a larger mass, and the height stays the same. This will be what happens, right? If you gain mass and you don't gain height, then your BMI is going to go up. Simple as that. All right, now what about this one? As height increases, so if I imagine that's my same starting point, my BMI was 26, but I gained height, but I didn't gain mass, so I go this way, right? So if I gain height, as height increases, the BMI is shrinking, right? Because I'm gaining height, but I'm not gaining mass. So I'm moving up to different BMI curves. Right? It's shrinking, getting smaller. So you're gaining height, but not mass. There you go. Oh, and then how did I get these? Well, I just got these from again, the curve. So this was mass over height squared. If you just pick different values, you'll see. You can always graph it in Maple or something like that and see that this is what it looks like. So part A was proving this. Part B was proving this, right? If I gain mass but no height, I will increase my BMI. That's what the first one said. If your mass increases, your BMI increases. If I gain height but don't gain mass, then my BMI shrinks, right? I'm going to a smaller BMI curve, which is what this says, because I'm moving from 26 BMI to 22 BMI to 18 to 14, et cetera, et cetera.